All right, hello and welcome. This is going to be our lecture video for March 31st. I'm going to be using this worksheet here that's linked on my calendar to talk about how to pick the correct method to solve a system of equations when you're not being directly told to use either substitution or elimination. You can download this worksheet off my calendar if you want, although it wouldn't be very difficult for you to just add this into your notes because it's just 7 problems. You could just write the system at the start of each problem that I do. But if you want the worksheet, it's on my website. The directions here say solve each of the following with either substitution or elimination and state why you picked the method that you picked. So with problem number 1, what method looks best? Well, what I'm looking for is, if I want to consider elimination, as I'm looking for a zero pair. If I see a zero pair, then I can go right into elimination. I don't see that here, although these y's could be made into a zero pair very easily. If I'm thinking about substitution, I'm looking to see if a variable is already isolated, and I do see that here. And with both of the y's being isolated, this is actually a really good one to do a substitution, because what we do is we just set the right-hand sides equal to each other. All right, because we're effectively substituting the y in the first equation with the 3x minus 8 from the second equation. And it looks like this: 3x minus 8 equals negative 2x minus 8. And now we can just solve for x. We'll add 8 to both sides. 3x equals negative 2x. We'll add 2x to both sides. 5x equals 0. Divide both sides by 5. And we'll get x equals 0. And we can plug that back into either of our equations. Plug it in right there, and we get y equals 3 times 0 minus 8. Y equals negative 8. And then we can write our answer as an ordered pair: 0 comma negative 8. Double check with the equation that we didn't use, which is the top equation. Negative 2 times 0 is 0, minus 8 is negative 8. Negative 8 equals negative 8. It checks out. So let's write what we just did. I picked the substitution method because both equations already had y isolated, so I could set the right-hand sides equal to one another. All right, problem number 2, let's see. Elimination or substitution? Well, this one, I'm going to use elimination. And the reason is I already see a zero pair. This x and this negative x make a zero pair. Everything's nicely lined up too. That's just an added bonus. And I can just straight away put a plus sign in front, addition line underneath, and start adding together my equations. The x's cancel out. Negative 2y plus 8y equals 6y. 0 plus negative 6 is negative 6. Divide both sides by 6 and get y equals negative 1. Go and plug that back into either equation. Plug it in right there. And I get x minus 2y, but y has been replaced by negative 1, equals 0. X plus 2 equals 0, minus 2 minus 2, x equals negative 2. We get the ordered pair, negative 2 comma negative 1. Double check with the second equation. 2 minus 8 equals negative 6, negative 6 equals negative 6. It checks out. All right, so for this one here, I picked the elimination method because the x's already formed a zero pair and could be eliminated easily. All right, let's look at number 3. All right, what method's going to work best here? Do we have a zero pair? Doesn't look like it. Is a variable already isolated? Yes. The y in the top equation is already isolated, so I'm going to use substitution. Because that y is isolated, I'm just going to box the other side and draw an arrow to the y in the second equation, because this y is going to get replaced with this expression. All right, what's that going to look like? I get negative 2x minus, in parentheses, 7x plus 20 equals negative 2. So this is that second equation, with just the y replaced with this here. But now x is my only variable. I can solve for it. Negative 2x minus 7x minus 20 equals negative 2. Combine like terms, I get negative 9x minus 20 equals negative 2. Add 20 to both sides. Negative 9x equals 18. Divide by negative 9. X equals negative 2. I'm going to go plug that back in to the top equation. And now I get y equals 7 times negative 2 plus 20. Y equals negative 14 plus 20. Y equals 6. All right, final answer. Negative 2 comma 6. I'll box that. Actually erase these. Just want that final answer boxed. All right. There, I think that looks better. We use the top equation to solve, so let's use the bottom one to double check. This would become 4 minus 6 equals negative 2, negative 2 equals negative 2. It's double checked. All right, so for number 3, I picked the substitution method. Because y was already isolated in the top equation, which made it easy to substitute into the second equation. All right, number 4. All right, do we already have a zero pair? No. Is a variable isolated? No. So maybe we consider elimination again. Even though there isn't a zero pair, would it be easy to make a zero pair? The answer is yes, because we've got an identical pair here, the negative 7y and the negative 7y. All we have to do is multiply one of these by negative 1, and we will get a zero pair. So I'm just going to copy down that top equation. So I'm just going to say times 1, I'm copying it. For the bottom equation, I'm going to multiply by negative 1, and I get 6x plus 7y equals 14. Now I do have a zero pair, and I can add these together. I get negative x, these cancel, but I have to leave something, equals 0. If negative x equals 0, then x equals 0. Go ahead and plug that back into either of these. I'll plug it into that top equation. Negative 7 times 0 minus 7y equals negative 14. This cancels out. Negative 7y equals negative 14. Divide both sides by negative 7. Y equals 2. Let's double check with this equation here. 0 minus 14, negative 14 equals negative 14. Yep, it checks out. So 0 comma 2, final answer. And we did our double check. All right, so for number 4, which method did I pick? I picked the elimination method because I could easily form a zero pair by multiplying the second equation by -1. All right, problem number 5 is a bit of a toss-up, but I would say the tie break here is the fact that the top equation is not in standard form, which makes elimination just slightly more difficult because your like terms won't be nicely lined up. So that's why I want to go with substitution with problem number 5. I can easily isolate this x by just adding y to both sides here. I get x equals y plus 1. I can put a box around this side here and plug it in for this x right there in the top equation, creating the equation -8y plus 16 minus 4 times y plus 1 equals 0. Going to distribute the -4. I get -8y plus 16 minus 4y minus 4 equals 0. Combine like terms, we get -12y plus 12 equals 0. Subtract 12, subtract 12. -12y equals -12. Divide by -12. Y equals 1. Alright, gonna go plug that back in. The easiest place to plug that back in is this manipulated equation here because it's already solving for x. And we just get x equals 1 plus 1, x equals 2. Ordered pair 2 comma 1. Alright, let's make sure that works with the top equation. -8 plus 16 is going to be +8. Minus 8 equals 0, 0 equals 0. That checks out. Alright, so what method did we use for number 5? Number 5, we used the substitution method. And we did this because it was easy to isolate the x in the bottom equation and the top equation wasn't in standard form, so like terms were not lined up, which would make elimination easy. All right, number 6, 2 more. All right, which method would be best for this? I think elimination. And the reason is it would be somewhat difficult to isolate a variable here. It could be done, especially in the bottom here, because everything is divisible by 4. And I could get one of those variables by itself. But I think elimination is going to be easier just because these are in standard form. You got like terms lined up. And we do have multiples here. -12 is a multiple of -4, so we can get a 0 pair pretty quickly. What I'm going to do is I'm just going to copy that top equation. So just times 1. 5x minus 12y equals -13. And then I'm going to multiply the bottom equation by a -3. And that's going to give me a 12y, which is the 0 pair of -12y. So let's see, I get a 12x plus 12y equals -72. Now I can add them together. That's going to become a 17x. These will cancel. And this becomes a -85. So I got 17x equals -85. Divide both sides by 17. X equals -5. Plug that back in. I'll pick the top equation. 5 times -5 minus 12y equals -13. Negative 25 minus 12y equals negative 13. Add 25. Add 25. Negative 12y equals 12 divided by negative 12. Get y equals negative 1. Write it as an ordered pair. Negative 5 comma negative 1. I use the top equation to solve, so let's use the bottom equation to double check. 20 plus 4 is 24. That checks out. Whoops. All right, so on number 6, I picked the elimination method because it was easy to form a zero pair by multiplying the bottom equation by negative 3. Also, both equations were in standard form, which makes the like terms line up nicely. All right, last one. So number 7, this one does have a zero pair, and if you have a zero pair, you should go with the elimination method every time. The 2y and the negative 2y. It's going to be a little bit more tricky because like terms aren't nicely lined up, but I still think we should do it with elimination. So if I add these together, the 2y and the negative 2y are both on the left of the equal sign, so they can cancel each other out, leaving on that side of the equal sign just a 4x. On the other side, we've got a negative 20 and a negative 22. Those combine to be a negative 42, and we have a minus 2x over here. All right, time to solve for x, which means get them together. I'm going to add 2x to both sides. I'll get 6x equals negative 42, divide by 6, divide by 6. X equals negative 72, or just negative 7. Plug that back in. Plug it into that top equation. 4 times negative 7 plus 2y equals negative 20. Negative 28 plus 2y equals negative 20. Add 28, add 28. 2y equals 8, divide by 2, divide by 2, y equals 4. Get the order pair, negative 7 comma 4. I use the top equation to solve, so I use the bottom equation to double check. Negative 8 equals negative 22 plus 14, negative 8 equals negative 8. It checks out. Now we just have to write why we picked the method that we did. For number 7, I picked the elimination method because I already had a zero pair. And if you have one, you should just always use the elimination method. All right, that's going to be that for this video. Rest your